Hello there. This video may be in two parts or three parts, I don't know yet. Is dealing with units for measuring area, volume, square root, cube root, etc. etc. So we're dealing with units of measurement. See, in order to measure anything, you need a unit, something to go by, okay? So, uh, speed, meters per second, can you see that? Kilometers per hour. Mass, kg, grams, pounds. TOWN is a metric ton, which is a thousand kg. Volume, centimeter cube, meter cube, millimeter cube. Area, centimeter squared, meter squared, millimeter squared. Okay, now we go for page 2. There are about 16 pages. Page 2. Okay. Um, Imagine a square. Okay, this square has got a side of 1 centimeter. You know what a square is? All the sides are equal, all the angles are equal. So the size equal to 1 centimeter. Okay. Now the square is supposed to occupy only horizontal space. Means it's not high enough. Okay. Imagine a thick book. Okay. A book is high enough. It's so to occupy space horizontally and vertically. But this is like a flat piece of paper. Let's call it a tile. So the space. How now the thing is, mathematicians wanted to measure this horizontal space. So they gave it a name and called it area. So this is this here. The square is taken as the unit of measurement of area, valued at 1 square centimeter. Let's see if you understand that. See, the area of this is 1 into 1. So 1 square centimeter is the area occupied by it. This is used as a unit of measurement of area. So suppose a floor has a hundred of these tiles which fit exactly. Then the area would be 100 centimeters squared. Okay, right? Look here in this figure, ABCD is a large square comprising 9 unit squares. There are 9 of them. Can you see that? 369. Each one is a square of this size. So the area will be 9 into 1 centimeter squared. Note, a perfect square is the one where the side is a natural number. Okay, perfect square. Got it? So see here now, this square here, PQRS, the side is 2.3. This is not a perfect square. Got it? Look at this. Square root concept using area. And also demo problem. See this square, as you come back to the square. Um, Let me go back to that for a minute. In the square, you see the square's got sides of 3 and 3. Okay, so the area is 9 centimeter squared. Okay, coming back here. The area of the square is again 3 into 3, 9 centimeters squared. Now, let's come to the idea of square root. This is a picture form of a square root which you must have in your mind. The side of the square is equal to the square root of the area. Got it? So that means 3 is the square root of the area. Now, try to memorize this notation. It's very, very important. The smaller one is the root. In a tree, the root is the smaller part, right? Try to remember that. This is 9, which is the larger one. So this requires a tree. This is a square root. Nothing great about the figure. Have a look at the figure. Okay. So the area of the... No, take another square. See, 16 by 16. So the area is 16 squared, which is 256 centimeters squared. So the side of the square is the square root of the area. Now you must be able to oscillate back and forth. You must be very good at this. So from this, you must be able to show that 16 squared. If you want to remove this, I'll call it an umbrella. So if you want to remove the umbrella, this becomes a square and the umbrella goes. Got it? Take a problem. I want to find the square root of 225. So the first step is obviously always to break it up into its prime factors. Okay, since we're dealing with square root, we must take it in pairs. 2 5s make 1 5. 2 pairs. 1 pair of 5, 1 pair of 3. So replace each pair by a single number, like 5 into 3. So this is replaced by 5. This is replaced by 3. 5, 3 by 15. So this is the square root of 225. See, try to oscillate, okay? Learn how to oscillate. Please note 15 squared is 225. Okay, so that's enough for this video.